Another application for the shotcrete process is the reinforcement of mines, tunnels, and other underground work.
On major projects such as a tunnel, we can handle more volume than a man is really capable of. So the mechanical, I don't like the word robotic because that kind of indicates it'll be automatically good concrete. The fact is, if you don't know how to use it properly, it'll make a bigger mess faster. All right, Jason's going to do a little typical underground work in the tunnel. Mining and tunnel construction is still on a smaller scale done by hand. Show that technique, and you can see already when you get above that 4-foot level, it becomes really tough work for the nozzleman. So we'll kick in the mechanical nozzleman here in a little bit and finish up the rest of this tunnel. And we've just taken the wet hose that Jason shot this corner of the slope and the wall of the tunnel with and hooked it up to the mechanical man. And this is a guy we can put twice as much material through and he'll never get tired. So what Greg is doing is just transferring the accelerator line over to the Aruga. This controls from a very sophisticated dosing and metering system the quantity of accelerator that goes in at the nozzle to the mix. We're using a 3% dose here, 3 to 4% dose. And if you change the stroke on the pump to increase or decrease volume, the volume of accelerator is also matched accordingly. For overhead applications, this is the must. There are other advantages with mechanically held nozzle too. You can turn the air velocity up with beyond what a man can really handle well. And that separates the sausage. What we're doing here that's different than dry. In the dry process, you're metering granular material into a moving airstream, 300 or 400 feet per second. And it impacts the surface at that same velocity. The oscillation that you see in the nozzle here is just to spread the material out in a more controllable manner. Otherwise, you'd build up too much material in one spot. We'd have bumps all over the wall. Now, that oscillation is an automatic function. The rest of it is just Nintendo skill, hand coordination. Normally in a tunnel it's constructed in this manner. These are called lattice girders, and this lattice girder is a typical support in a subway system. In fact, this dimension of these lattice girders is a standard single-track subway system that you might find in New York, Washington, San Francisco, any of the major cities in the country which have a transit system. And after the ground is excavated, depending on the type of geology and the initial support component, which could be a rock bolt system, the lattice girders are stood and then shotcrete is applied for a primary support component. The lattice girder has to be fully encapsulated. It's reinforcement, just like the bars you saw down in Casey's wall. And that takes high velocity and a good flowable material. At the same point in time, as we're working up the vertical side and then overhead, the accelerator will react with the cementitious component in the concrete and cause it to approach initial set in a matter of a couple of minutes. A short period of workability, so there's plenty of plastic flow around the girder, and then it'll set.